name is Arun, and I am Vice President at a company called New Algae Nanobiotech in Bangalore, here in India. And today I'd like to talk about some of our thoughts on bioremediation of lakes using the use of certain plant growth supplements that I would like to introduce to the group here. Our company is a research and development firm as well as manufacturing firm. Just to briefly introduce to you, what we do. We have a division in water where we make products for improved nature-based rejuvenation of lakes, rivers, and ponds. We have a product for aerator-free sewage treatment plants and a separate product for the aquaculture market. On the agriculture side, we have products that improve soil health. We have a product to boost photosynthesis and improve yields, and a separate product for enhancing the performance of turfs, as well as the visual aspects for turfs used in golf courses and sports stadiums. So we are a small firm where we do research and development and manufacturing these products. And we have been in the market for a number of years. Myself, just as before I go a little bit into the topic, I just wanted to introduce myself to you. Prior to coming to New Algae Nanobiotech, I worked at a solar photovoltaics firm, startup called Sun Edison. Many of you might have heard about it. It's in the solar. I was head of research and development in the field of solar photovoltaics. And before that, I was at General Electric in their research and power divisions here in Bangalore at the John F. Welch Technology Center. So I was a research scientist at General Electric. Prior to that, until about 2013, I was working in the United States as a scientist at the Lawrence Livermore National Laboratory. So I worked there for about 6 years after my PhD. And I had completed my PhD and my master's degree at Stanford University, also in the United States. So that's my background. So my background is in physics, computer science, electrical engineering, sensors, and using these technologies for sustainability and remote sensing and climate change applications. So there has been a sort of a steady theme of sustainability and climate change related problems that I've been addressing through different technologies that I've been working on over the years. And this is my latest foray into, consistent with that theme, but into the field of water. Previously, I've been working a lot in air and energy related fields before. So with that background, I'd like to tell you what are we trying to solve as in this company. We are essentially looking at some of the high-level problems that we face as a society, right? We have diminishing fish yields, mass fish kills in all sorts of water bodies. We have harmful algal blooms. We have lots of lakes where water plants are beginning to occupy greater and greater fractions of the water bodies. We have diminishing biodiversity. We have diminished soil health for agriculture. And of course, reduced water quality for human consumption and recreational activities. If you look a little bit deeper, the causes for these things are the following, right? You have excess nitrogen and phosphorus compounds in the water. You have a lot of heavy metals. You have low levels of dissolved oxygen, high levels of organics, accumulated sludge in the bed of the lakes and the water bodies. You have lots of mosquitoes and pathogenic bacteria, and a water environment that is very diseased.